this video, we're going to talk about these terms. I've actually already mentioned these terms before. We're going to break them down a little bit more, really focusing on experimental probability. So you got experimental probability and theoretical probability. Now, what you have here, we talked about these definitions before, but when you talk about theoretical probability, that's what should occur. Experimental probability is what actually occurs when you conduct the experiment. And so we're going to focus on this chart right here. What this is, it's actually showing sample space. Remember, sample space is just a set of all possible outcomes when you do an event. So this is actually the sample space you have when you roll two number cubes. Remember, number cubes are like this here, so it's like dice pretty much. And so here it's basically saying you could roll a 1 on the first one and a 1 on the second one. 1 on the first one, a 2 on the second one, and so forth. Same thing over here, you got a 2 on the first one, a 1 on the second one, 3 on the first one, 1 on the second one. So all these different choices that you see in here on this chart represents the sample space. And as you can see, you have 36 possible choices that could happen. In other words, 36 possible outcomes when you roll a pair of dice. In other words, two number cubes. So if you go back in and look, we're going to talk about rolling doubles today. So you look at this chart, and you have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So you have 6 possible doubles out of a total of 36 possible outcomes. So I'm going to come back and start to do some experimental probability and theoretical probability here. So first things first, we want to find the theoretical probability. Remember, that's what should occur. Theoretical probability of rolling doubles. We just saw we have 6, going back to that fraction that we use to solve probability, 6 choices make us happy out of a total of 36 possible outcomes. So 6 out of 36. You can reduce this down by dividing by 6 on top and bottom. So therefore, the theoretical probability of rolling doubles would be 1/6. So that's what we should get. So when we're rolling doubles here, we should be rolling these dice here and trying to get doubles. Pretty much every 1 out of 6 rolls should pop up being doubles. We're going to do some experiments here in a second, or an experiment that goes back in and shows us the experimental probability of rolling doubles. So let's take these dice. And we're going to go, we'll do it 10 times. So I'm going to roll, hopefully I'll roll in the screen here. So you got 1, let's see, we got a 6 and a 3. So I'm going to do a little track over here. So I'm going to put D for doubles, and then ND for not doubles. So we got 1 that's not doubles. Roll again here. This one's a 6 and a 2. So we got 2 for not doubles. Do it again. Up there we go. We got 2 6s, so we get a double. Roll it again. We got 3 and a 2, so not doubles. Roll it again. That one's actually a 6 and a 6 again. So we get 2 doubles. Here we get a 4 and a 1. So not doubles. Here we get a 2 and a 1. So not doubles. We have 3 more rolls. 5 and a 3. So not doubles. 4 and a 3, so not doubles, and here we had a 6 and a 2, so therefore it's not doubles. Now, in this situation here, we had 2 out of a total of, remember we did 10 total rolls, so we come over here for the experimental probability, 2 doubles out of a total of 10 rolls. So when we reduce this down, we can divide by 2 on top and bottom. So we will get 1/5. Now you notice our experimental probability is not the same as our theoretical probability, and that happens from time to time. If you actually want to see which one of these is bigger, one thing I've shown people in the past is I'll say, well, is your experimental probability higher or lower than your theoretical probability? I don't know. So remember, it's something you've probably already done in the past before, if you ever want to compare fractions. So here's our experimental probability, 1/5. Theoretical probability here is 1/6. You can cross multiply. So 6 times 1 is 6. Circle that up there. 5 times 1 is 5. So therefore you see that what we got is actually higher, because 6 is higher than 5. What we got is actually higher than the theoretical probability. I'll put the greater than sign down there. So what I want you to take away from this video is the more you do the experiment, so we only did 10 rolls, the more you do the experiment, the closer your experimental probability should get to your theoretical probability. So let me say that again. The more you do an experiment, the closer this number you get for the experiment, your experimental probability, the closer it should get to the theoretical probability. So I've done this in years past. I've had people, I typically do 30 rolls when we do this in class, but I've had people get right on the theoretical probability when they do 30 rolls. I've had people get lower than the theoretical probability. I've had people get higher than the theoretical probability. But what I always want them to take away is the more you do the experiment, the closer the number you get for the experiment should get to the theoretical probability. So that's just a little example of experimental probability for this video here. All right, see you.